Today I will explain that very important uh, points, that is d pi p pi and p pi bonds. So how to calculate it whenever they will give the molecule in entrance exam, how to calculate d pi p pi or p pi bonds. So or sometimes the combination of both. So I will tell you a small trick to find out the p pi and d pi bonds. So I will take first example, carbon dioxide. This carbon dioxide, first you have to find out that the first step you have to find out that hybridization. That hybridization equal to, already we discussed in previous video, that is V plus M minus C plus A by 2. This is a trick to find out the hybridization. So here hybridization equal to V means valency. The valency of the carbon is 4 plus any monovalents are there? No, 0. Any cation? No, anion by 2. That is 2 means one S and another one is a P. Now I will write the structure of CO2. This is a CO2 structure. So here generally p orbitals are three orbitals, that is a px, py, pz, and d orbitals are 5. So here one s orbital, one p orbital is there in hybridization. So here remaining one p orbital is there. So remaining how many p orbital left out? Two. That is here, that is a p pi, then p pi bond one. Another is a p pi bond. So that here, that is a p pi bonds are 2. So 2 p pi bonds. For example, I will discuss another example. So here we are taken the SO3 molecule. SO3. SO3 here, S is sulfur, that is a S group number, that is a sixth group number. So here hybridization equal to 6 plus 0 minus 0 plus 0 by 2. This is a hybridization technique previously we discussed already. So that here 3 sp2. So here we wrote again, here lone pairs. How many lone pairs are there? 3 minus 3. Whatever that we get answer, minus number of surrounding elements, that is a lone pairs are 0. So here I will write the structure as double bond O, here double bond O, then double bond O. Here how many p orbitals are sp2 now? So here p exists in 3 orbitals, that is px, py, pz, that is suborbitals, d are 5. So already p 2 are over in hybridization. Only remaining one, maybe it is a p pi, p pi bond. Remaining two pi bonds are, that is a d pi, p pi bonds. So remaining two are d pi, p pi bonds. So here the p pi bond is 1. Again d pi, p pi bond 1 is 1. Then remaining this one also d pi, p pi bond, that is also 1. So finally we wrote conclusion, p pi bonds are 1. Again d pi, p pi bonds are 2. So total how many pi bonds are there? Then total molecule 3. So we get 3. Similarly, we have to explain that SO4 minus 2. This is actually H2SO4. So here again I will write the structure S double bond O, then double bond O, O minus, then O minus. This is actually structure. This is a double bond O. So here we wrote the hybridization equal to, that is a 6 minus plus 0 minus 0 plus 2 by 2, because minus 2 now negative. So that is this a 4 means sp3. So here I will write this structure again one more time for clarification. Double one O, then double one O, O minus, here also O minus. In this case, here sp3 is there. So already three orbitals, p orbitals are over. Remaining two are, this is a d pi p pi bond, and another one also d pi p pi bond. So here p pi bonds are 0, then d pi p pi bonds are 2. Here again one more example I will explain, XeO3. XeO3, here hybridization equal, that is already we discussed that hybridization is sp3. So here XeO3 now, so that here number of lone pairs, here 4 now, 4 sp3. So here lone pairs are 1. So here we wrote a structure. This is a double bond O, then double bond O, here double bond, then this is a one lone pair. Okay, so here sp3 means that is already p exists in p orbitals are 3, d orbitals are 5. So already p are over. Remaining all are this is a d pi p pi bond. This is also d pi p pi bond. This is also d pi p pi bond. So p pi bonds are 0, then d pi p pi bonds are 3. Now I will discuss another example. For clarification, you have to discuss everything, that is XeO3F2. So here hybridization is sp3d. So because xenon is sp3, then here monovalents, how many are there? 2 by 2. So monovalents by 2. So here how many? Only 2. 2 by 2 means 1. sp3d. This is actually 5. So we wrote again structure, that is Xe double bond O, then double bond O, then double bond O. One fluorine is bottom, another fluorine is top. So here sp3d, so hybridization is sp3. All uh, three p orbitals are over. P orbitals are over. So only d orbitals are 5. So the remaining here d pi p pi, d pi p pi bond is 1. Here also these two also same thing. So here d pi p pi bonds are 2. So here p pi bonds are 0. Then d pi p pi bonds are 2. Sorry, 3. 3. So total p pi bonds are 0. D pi bonds are 3. So similarly, we discussed that remaining. You take any molecule, we can check it out whether this trick is worked out or not. So if it is any doubts for clarification, so for clarification, you can fill in message or send it in the comment box. Thank you.